After a certain point in your life, you solve so many quadratic equations that you don't really have the strength to do it with pen and paper anymore. You just want to write the three coefficients and by magic you have the answer. So let's try to create this program with Python. From my perspective, programming and mathematics are interconnected. In order to create complex programs, you need mathematics to structure your way of thinking and the final solution. On the other hand, programming and more specifically repetitive process help mathematics to solve very complex equations that are nearly impossible or actually impossible to solve with pen and paper. The interesting part starts when you think that you can have the solution of any quadratic equation just by writing the input a, b and c.
This is very easy, I can do it with my mind.
Okay, what about this equation? Believe me, you can solve this equation with a computer too, just by adding 3, 1, 6, 2 and 5. But for educational reasons, we want to start small. Let's assume that you have this equation. So a is equal to 1, b is equal to -3 and c is equal to 2. The discriminant is d is equal to 1 and the solutions are 1 and 2.
Okay, we will create a program that calculates the discriminant in a variable and then use it in the classical equation in order to find the two solutions.
A part of our final program is this procedure, but you should consider one or two more cases. We can try to create this part in Python. Okay, first we need to initialize the three variables. This can be done by the user, but here we will just write them down in order to make the whole procedure faster. So a is equal to 1, b is equal to -3 and c is equal to 2. Then we need to calculate the discriminant, that is equal to b squared minus 4 multiplied by 8 multiplied by c. And we can print the results. So the results are correct. In addition, we will calculate the x1. For this equation, we need to use the square root of d. Fortunately, Python has already embedded the equation sqrt that can do the trick. But first, we need to import a math library. And then we can call the square root function. For example, we can write math.sqrt of d. And we can print the results. So everything is okay. With that being said, x1 is equal to this equation. And we can print the result. The same goes for the x2. And as you can see, the results are the same with the analysis in the animation. Now we want to go to the next level and create the whole algorithm that can create different paths for different cases. For example, if discriminant variables is equal to 0, you will have only one result, and if d is less than 0, you will have imaginary results. Also, don't forget that if a is equal to 0, you should not use the classical equation, because you will have a division with 0. In order to implement this in Python, we will use the if statement that we have learned in the previous video. So, if d is greater than 0, else if d is equal to 0, and else. Then we will use the same algorithm inside the d greater than 0. In the case of d is equal to 0, we have only one solution two times. So x1 is equal to this. And we will print it. Finally, for the d less than 0, we have complex algorithms. So z1 is equal to complex, and we have two numbers, the real one and the imaginary. So the real one is equal to minus b divided by 2 multiplied by a. And the imaginary is sqrt of d divided by 2 multiplied by a. And we will print the z1. Then the same goes for the z2. So now we can use the algorithm. For the previous coefficients, we have these results. Then if we use these coefficients, we will have these results. Okay, the problem is that we forgot that here we need minus d because d is less than 0. As you can see here, we have the correct results.